Hi everyone and welcome to Factorising 101. This is just a little introductory video into the first 5 steps in factorising. Now, a couple of things up front. These are not necessarily the only methods to factorising, okay? If you find something else from somebody else, feel free, use it, so long as it works for you. Second thing is, this is a bit like learning how to walk before you run, okay? There are calculators out there which will do this in a click of a few buttons, but this is about learning the processes and trying to learn why and when we're going to apply these things. All right, so to start off with, there are 5 steps and we have to do these steps in order. First step is we want to look for a highest common factor. Second step, looking for difference of 2 squares. Third step, monic trinomials. Fourth step, non-monic trinomials. And the fifth one is completing the square. Now we're going to go through these in different sections, so if you want to write those 5 steps down, I recommend to my students that we all write those 5 steps down and you're always going to reference them. Okay, let's go for the first one, highest common factor. Now, first up, we want to take a look at this sentence in red. You're looking for a number, pronumeral, or term that will divide into other terms in the expression. I actually don't like the way that's worded. I think it's better if you're dividing things out of the expression. That's what a highest common factor does. It finds what's common to both bits, or all 3 bits, however many bits there are, pulls it out the front, and then you've got the leftovers in brackets. All right. I'll go through the steps in a second. It's probably best to show you with an example. So I'll do the first one, 3x plus 12. Now, obviously, the thing that is common there is going to be the 3. 3 goes into both the 3x and the 12. So I'll write out the side here, HCF, highest common factor, equals 3. So what we do with that is we write that down underneath. Open a bracket. Now, see how I've left some room there? What we're doing is we're dividing out of that expression, the 3. So we're going to divide both of those bits by 3. 3x divided by 3 leaves you with x. Bring down the plus. 12 divided by 3 is 4. Close brackets. That's it. Now the biggest mistake people make is they forget to do the second term. Please remember that. Okay, let's have a look at the one down below, 4 plus 24p. Common factor. Now, it could say 2 goes into both. Is that the highest common factor though? Remember, ideally we're looking for the biggest one. No, 2 is not the biggest. 4 is the biggest. So HCF is 4. Okay, pull the 4 out the front. We're going to divide both terms by 4. 4 divided by 4 is 1. Bring down the plus. 24p divided by 4. So 24 divided by 4 is 6. And the p is still there. Close brackets. There's our answer. All right. Now, if you've done that one and you had used 2, doesn't matter. 2's out the front. That's fine. But you'll see in the brackets, you'll have a couple of 2's in there as well. So all you have to do is do the process again. Okay. Best though, get the highest common factor first. Now, remember at the start I said it could be a pronumeral as well. Look at this one up here, 4a minus 9a. You can see that the a is common. So my HCF equals a. A comes out the front. Now it's divided by a on both terms. Cross out the a's and I'm left with the 4. Minus comes down. 9a over a, cross out the a's, you're left with 9. Okay, now, actually I'll just extend that one. What's 4 minus 9? All right, negative 5. Now keep that in brackets, a. So we can rewrite that as equals negative 5a. Hey, we could have simplified that without using factorising, couldn't we? But that's just a good way of showing that the steps, how it all comes out in the end to be the same. Let's move down to the one below, 7b squared plus 14p. Okay, now 7 and the 14, that's great. We've got a HCF of 7, but we've got p squared there and we've got a p over there. That means we've got a p that's common to both. Not the p squared, just one of the p's, because in the second term over here, we've only got one p to get rid of, so it can only be one p. All right, let's put the 7p out the front, open brackets, right, over 7p over 7p. Now, 7's cancel out. One of the p's goes from the bottom and one of the p's goes from the top. So you can see we're left with a p. Bring down the plus. 14 divided by 7 is 2. And the p's cancel out. So we're left with 7p brackets p plus 2. Now, let's get some negative stuff going. Negative 7p minus 14p. Where you can, it's a good idea to get rid of a negative as a highest common factor. So in this case, you can see the numbers are the same to the previous example, they're just negatives. So we'll make the HCF negative 7p. Pull the negative 7p out the front. Now divide by negative 7p, divide by negative 7p. First one, negative 7's cancel out. That's still left with a p. Now, we've got negative 14 and negative 7. This is where you have to be careful. You've got a negative and a negative. What does that turn into? Correct? A positive. P divided by P disappears, and 14 divided by 7 is 2. So it still stays as P plus 2. Sorry, it turns into P plus 2 from a negative. Watch the negatives. Last one. Now we've got 3 terms in this one. 5x plus 7x squared minus 3c. Now the x's are common in the first two, but not the third. So we can't do it for every term, but that's okay. We can get the first 2 terms out of the way. So the highest common factor, I would underline the first 2 terms. Highest common factor of that is just x. So I'll rewrite that as x brackets. Now divided by x divided by x. So 5x divided by x is 5 plus, now the 7 comes down and we've gotten rid of one of those x's, so it's 7x. What do we do with that minus 3? It just stays on the end. There's nothing we can do with it because it's not an x, and the 3, 5 and 7 don't factor out either. So hopefully that'll get you going on the highest common factor. Good idea to get some notes down on that, get some practice on it, because we are going to build on it. The next slide gives an example of why we might want to do some factorising. Yes, it's the dreaded worded problem. Don't know why people panic about this. You just got to remember, we're just doing algebra. All we're doing is converting a sentence or a couple of sentences into some mathematical equations, and we're going to potentially solve them. All right, let's have a look at this one. A rectangular box has an area of x squared plus 4x. So to me, the first thing I want to do is I want to underline the important bits. So it's a rectangle, it has an area, and there's what our area is, x squared plus 4x. Now, area of a rectangle, I know what that is as a formula. So that's A equals length times width, or L times W as I've written. And we know that equals x squared plus 4x. Now that doesn't really look like a length times width, does it? We've just been doing some factorising, pulling a highest common factor out the front. And that highest common factor multiplies by the leftovers in the bracket, doesn't it? Hey, that could be our length times width, couldn't it? All right, let's draw a box. Click, there's a box. Look at that, magic. In there, we'll write A equals x squared plus 4x. Okay, what's the highest common factor of that one? Is x, correct. So we're going to divide both sides by x. So underneath, A equals, highest common factor at the front is x bracket. X squared divided by x is x. Bring down the plus. 4x divided by x is 4. Close brackets. So what that means is our x is our length times the brackets is our width. Okay, let's write that on the side of our box. X goes up there, and the x plus 4 goes down the bottom as our width. What's the point of that? Well, that actually sets up a model, so we can check, we can substitute, we can try different numbers. If we know what our length of our room or our farm or anything like that, a rectangle, if we know the width of that and we use this model, then substitute, say, 3 metres there, and we'll put the 3 down in place of the x on the width. That's 3 plus 4 is 7. I know it's going to be 7 metres wide. If it was 5 metres in length, then 5 plus 4, it would be 9 metres in width. So it just helps us predict what dimensions are going to be. Now that's just a simple example. There are plenty of worded problems, but they're all the same. Doesn't matter what the shape you've got, draw the shape, write the equation to work out the area or the perimeter, or see what you can simplify, and factorise, and you will have a mathematical problem very quickly instead of a worded problem. Excellent. Now you've had plenty of practice with highest common factors. It's time to look at step number 2, which is actually probably the easiest one to recognise. It's the difference of 2 squares, or shortened to dots. It is literally that. It is literally 2 square terms that are separated by a minus sign. That's what you're looking for. You can see in the box there, I've written the whole thing, a squared minus b squared equals brackets a plus b, brackets a minus b. If you want to work it out and prove it, feel free, knock yourself out, go and expand those brackets, and you'll see that you get back to a squared minus b squared. All we're looking for are 2 squared terms separated by a minus sign. Let's have a look at the first one, x squared minus 25. Now the x squared is a square term, obviously. The minus is in the middle, that's what we're looking for. And 25, well, 25 is a square number, isn't it? Okay, so all we're going to do is we're going to write our 2 pairs of brackets. Leave plenty of room because you're going to be writing in them. Okay, what is the square root of x squared? Correct, it's just x. So put an x at the start of the first one, an x at the start of the second one. Now, go and put a plus after the first x, a minus after the second x. What's the square root of 25? 5. So put a 5 in the first bracket, a 5 in the second bracket. Done. Have a look at the one down the bottom. X squared plus 100. We've got an x squared, that's a first bit. 100 is a square number, that's great. But we've got a plus in the middle, haven't we? No, that's no good. You can't dots that one because it's not a difference. So that one you can't factorise. Watch the pluses. They sneak them in exams. Hint, hint. All right, third one. C squared minus 81. C squared is square. 81 is square, and there's a minus in the middle. Meets all our criteria. So do our 2 sets of brackets. Square root of c squared is c. Goes at the start of the first and second. Put a plus and a minus. Square root of 81 is 9. Done. Now, let's go down the bottom. X squared minus 13. We go square at the start. We've got a minus 13. 13 is not a square number. Well, any number can be a square number actually. It's just not a perfect square. So this rule still applies to this one. So do our 2 sets of brackets. We've got an x at the start. We've got a plus. We've got a minus. Now what's the square root of 13? Yeah, just the square root of 13. Just write the square root of 13. That's all it is. You can't simplify it. You can write it as a decimal if the question you are doing allows you to write it as a decimal, but and then you go for the calculator. Last example, 49 minus p squared. That one's round the wrong way. Doesn't matter. Is 49 a square? Yes. Is it a minus? Yes. P squared, that's a square. Doesn't matter. It's just round the other way. So square root of 49 is 7 goes at the start. One's a plus, one's a minus. P squared becomes P and P. That's it. That's all you need to think about with this one. Is it a difference? Are they two squares? That's all. Separate them in brackets. Done. Number 3 out of 5 now. Monic trinomials. Now, that's just a fancy word, but it just means you've got 3 terms and there's nothing outside the front of the x squared term. Well, not technically correct. That means there is a 1. You've got 1x squared there, but we don't write the 1, so it's considered monic. 1 means mono. So we have an equation that looks like, and sometimes it'll have the y equals. Doesn't have to. It can just have the x squared plus something x. We'd write that as a bx plus c. So we're looking for an x squared plus bx plus c. Best way to get into this is obviously with examples. Okay, first one. X squared plus 5x plus 6. Now, what we're looking for, and this really works your times tables, particularly with the bigger numbers. You are looking for 2 numbers that multiply together to equal the 6, and those same 2 factors, they're called, those same 2 factors will add together to equal the b term, which is 5. So if you do it in those little boxes like I've just done underneath, and then under the c term, the 6, write a times, and under the b term, the 5, write a plus. Now, so we're trying to think of 2 numbers that multiply together first to equal the 6. So let's start at the bottom. 1 times 6. That equals 6. Great. We want to try those same 2 numbers to see if they add together to equal 5. 1 plus 6 equals 7. So they are not the factor pairs we want. All right, what else equals 6? 2 times 3. That equals 6. Try those numbers over here. 2 plus 3 equals 5. That is correct. They're the pair we want. So all we need to do then is write brackets, x plus 2, which is our first number, brackets, x plus 3, which is our second number. And we factorised it. Again, if you want to prove it, I'm sure you know how to expand brackets by now. You do your x squared, x times x is x squared, plus the x times 3 is 3x, plus 2 times x is 2x. So that becomes our 5x in the middle. Then you do the 2 times 3 equals 6 on the end. So you can see it's exactly the same thing, but just in factorised form. All right, let's go across the way now. X squared plus 9x plus 20. Same deal. Write your box 20 underneath, your 9 under the b term. They're the numbers we're looking for. It's a good idea to do this, even though the numbers are there. It's a good idea to do this because the next step is non-monic, and there is one other little step which changes things, but if you do the boxes, it makes it obvious and makes it a good habit. All right, times 1 times 20. Let's start at the bottom. That equals 20. Is 1 plus 29? No. 2 times 10 is 20. 2 plus 10 doesn't equal 9. 3 doesn't go into 20. 4. 4 times 5, that's 20. 4 plus 5 is 9. Excellent, that's the one we want. So, brackets, x plus 4, close brackets, open brackets, x plus 5 is our answer. All right, down here. Third one, I'll put a 3 at the front so you can follow it. X squared minus 5x plus 6. So, negative 6 goes under there. It's the first thing we got. Sorry, positive 6, not negative 6. Goes under there, and negative 5 goes under there. So, let's go through our factor pairs. 1 times 6 is 6, is 1 plus 6. Now, see, it's negative 5. Watch the negatives. This is 1 plus 6 equal to negative 5? No, it's not. It equals 7. Okay, 2 times 3 equals 6. 2 plus 3 is 5, not negative 5. Okay, so how are we going to do this? Now we need to multiply together to equal a positive 6, don't we? So you can do a positive times a positive, or you can do a negative times a negative. So let's try negatives. Negative 1 times negative 6 is positive 6. Negative 1 plus negative 6. So that plus negative in the middle turns into a minus. So negative 1 minus 6 is negative 7, not negative 5. All right, let's try the 2 and 3. Negative 2 times negative 3 is positive 6. Negative 2 plus negative 3. Plus minus becomes a minus, so negative 2 minus 3. Yep, that's the one, negative 5. Awesome. So, brackets, x, now it's minus 2. Close brackets, open, x minus 3. And that's factorised. All right, last one. Looks pretty familiar, but this time we've got our c value is negative 6 and our b value is positive 5. All right, so how do we multiply to get to a negative number? Now that means one of them has to be positive and one of them has to be negative. All right, so let's try negative 1 times 6. Well, that equals negative 6, doesn't it? Negative 1 plus 6. So negative 1 plus 6 is, oh, beauty, got lucky. That's 5. Got it lucky first time out. All right, so x minus 1, brackets, x plus 6. Okay, as you get more practice with these, you get to start recognising your positives and negatives. It really works your times tables, as I said earlier. So get some practice. Don't forget, though, if you come across a trinomial that has got a number out the front of the x squared, you can still look for a highest common factor to take that out, and that'll make it into a monic trinomial. So they sneak that in occasionally. Steps are here, get some practice, and I'll see you shortly for non-monic trinomials. Hey everyone, I just thought I'd sneak in a quick bit of revision now. If you remember back to the very start of the video, I mentioned these rules need to happen in order. Now we've done 3 of them. We've done highest common factor, we've done difference to squares, and we've looked at monic trinomials. But I just want to emphasise the importance of doing these in order. And a simile is, if we had an equation here in the box, 365 over 730 times 4. Ugly numbers, you could go for the calculator, but if you switched on at the moment, you'd see that 365 over 730 is actually just 1/2. It simplifies to a half. Much easier to say a half of 4 is 2. That's what factorising is about. That's one of the things factorising is about. When we start graphing, we'll talk about that when you sketch, but factorising is about making things simpler. Let's have a look at this example. 3x squared minus 12. Now we've got 2 terms, we've got a minus in the middle, the first one's got an x squared in it. That could be difference of 2 squares. But the 3 is not a square and the 12 is not a square, but then, hey, 3 and 12, 3 goes into 12, doesn't it? So we could do highest common factor. So HCF equals 3. So I'm going to divide by 3 both terms. We get 3 brackets. 3 divided by 3 cancels, so you're left with x squared minus 12 divided by 3 is 4. Oh, look at that. Now we have in the brackets, we have a dots, a pure dots. So we'll leave that 3 there, write the brackets. Now to do dots, we write our 2 sets of brackets. Square root of the x squared is x, and x, one's a plus, one's a minus. Square root of 4 is 2 and 2. Done. Looks much neater than 3x squared minus 12. All right. The second one, 25x squared plus 100x minus 125. Now, straight away, trinomial, but it's not monic. But 25 goes into all 3 things. So, let's pull a common factor out, 25. What's left? 25 divided by 25 is x squared. Plus 100 divided by 25 is 4x. Minus 125 divided by 25 is 5. All right, factors of negative 5 that add to positive 4. So now it's a negative 5, so one's going to be positive, one's going to be negative. Let's try negative 1 times 5, correct. Negative 1 plus 5, that's 4. Awesome. Now that 25 is still out the front, so we'll leave that in brackets. What are our two brackets we're going to write? X minus 1, brackets, x plus 5. Again, looks much neater. Now, just as a side, I'll give you, when we factorise, we're actually finding the x-intercepts on a graph. Okay, there's a little bit of fiddling that goes on with it, but when you start graphing, which is the extension of all this stuff we're doing in factorising, factorising gives you the x-intercepts. Okay, now it's time for step 4 in the factorising tree. It's non-monic trinomials. Now all that means is the a value, so the coefficient of the x squared term doesn't equal 1. It can be a positive number, it can be a negative number, fraction, decimal, doesn't matter. So long as there is a number out the front of the x squared term, that makes the trinomial non-monic. First example, 2x squared minus 8x minus 10. Now, remember the first three rules, highest common factor, dots and monic? They're all easier than these ones. So if we can convert these non-monics back into one of those, then it's going to make the job easier. First one to look at, highest common factor. Well, that's going to be the most common if you can do it. First one here, 2x squared minus 8x minus 10. We've obviously got a highest common factor of 2. So let's pull that 2 out the front. 2x squared divided by 2 leaves x squared. Negative 8x divided by 2 leaves minus 4x. Negative 10 divided by 2 is leaving you with minus 5. All right, non-monic, our C value is negative 5, our B value is negative 4. It's a negative, so let's start with our negative factors. Negative 1 times 5 is negative 5, that's good. Negative 1 plus 5 is positive 4. That's not the pair we want. Let's turn it around. 1 times negative 5. 1 plus negative 5 over here is negative 4. Yes, that's one we want. So, in our brackets, we're just going to have x plus 1, second bracket, x minus 5. Now, don't forget to put the 2 back. That 2 we pulled out the front. That 2 is still out the front. There's our trinomial factorised. Second one, 4x squared plus 8x plus 3. Now, we could go through and use a highest common factor. The 4 and the 3 is going to create a fraction though, and if we can avoid using a fraction, we will. So, to do this, we'll do this the true non-monic way, which is explained in the steps on the left. First thing we need to do is we're going to get rid of that, well, not get rid of it, we're going to use that 4. The 4 out the front, we're going to multiply by our C term. So 4 times 3 is 12. That becomes our new C term. Bring down the B term, which is positive 8. All right, so now we're just going to find our factor pairs of 12. So 1 times 12 is the first one. 1 plus 12 doesn't equal 8, does it? No. Second, let's go second try. 2 times 6 is 12. 2 plus 6 is 8. That's what we want. All right, this is where we go a little bit sideways from monic. So far, it's essentially been monic. Now it's not. Rewrite the equation, but what we're going to do is that plus 8x in the middle, we're going to convert that into its 2 pairs of numbers that we've just worked out. So rewriting it, 4x squared, so plus. Now instead of the 8x, we're going to bring down that 2 and write plus 2x. Then we're going to bring down the plus 6, so plus 6x. And finally, we bring down the 3 on the end. Okay, see how that's happened? We've brought down the 2x, we've brought down the 6x, 2x plus 6x is still 8x. So all we've done is split up that b term. Now we're back to highest common factors. We're going to group it into its two halves. So underline the two sections there. First section, is there a common factor? Well, yes, there will always be a common factor. So the common factor here, highest common factor, 2 is obviously going to go into both, but you've got an x in both as well. So the highest common factor is 2x. So brackets, we're going to divide the first bit by 2x, the second bit by 2x. 4x squared divided by 2x, 4 divided by 2 is 2. X squared divided by x leaves you with an x. Plus 2x divided by 2x is obviously just 1. Close brackets. Now, second one. They're both positive terms, so highest common factor there is obviously going to be 3. So plus 3 is our highest common factor. Brackets. Divide the first bit by 3, so 6x divided by 3 is 2x. The second bit, 3 divided by 3 is plus 1. Close brackets. Now, here's where you'd make a check. If those two brackets are the same, then you are on the right path. So 2x plus 1 is the same. That means we've got another highest common factor, haven't we? On the two sides of that plus sign, we've got a 2x plus 1. So that comes out the front, and what's left over goes in the brackets at the back. So we're left over, taking the 2x plus 1 out of the first half, we're left with the 2x, comes down, and the plus 3 comes down as well. If you're really not sure, you can expand those brackets and you should get back to 4x squared plus 8x plus 3, which was our original expression. Last one. This one's got some negatives, so we just have to, as always, be careful with the negatives. First step, let's get rid of that 2. 2 times the negative 6 equals negative 12. So that's our new c value. And our b term is, again, it's a negative. So it's negative 1. How many x's have we got? Negative 1. All right, 1 times negative 12 over here. 1 plus negative 12, no, it doesn't equal negative 1. 2 times negative 6. 2 plus negative 6 is negative 4, still not negative 1. 3 times negative 4. 3 plus negative 4 is negative 1, so that is our correct pair. Now we rewrite the expression. 2x squared. Now bring down the plus 3x, bring down the minus 4x, and finish it off with our minus 6 from the original. Okay, let's look for a common factor in our two halves of the equation. Now you see how I've written this second underlined part. I've included that negative in the negative 4x. Please do that. It's just a safety net. First section, common factor of 2x squared and 3x is just the x. All right, so 2x squared divided by x is 2x, plus 3x divided by x is just 3. Close brackets. Now remember when we said if we get rid of a negative, then that's good? Let's get rid of this negative because we've got negative 4x and negative 6. So our highest common factor is going to be negative 2. So negative 4x divided by negative 2 gives a remainder of 2x. Negative 6 divided by negative 2 is plus 3. Okay, here's our check. Are our brackets the same? Yes, they are. So they come out the front. 2x plus 3. Brackets leftovers is x minus 2. Done. Time for some practice. Well done, everyone. You've got to very close to the end of factorising. We're up to completing the square. Now, just a couple of points. This is what you do if you can't factorise any other way. Okay, so you've done the first 4, hasn't worked out. Now we can always complete the square. The other point you have to make is it has to be monic. Okay, even if your equation is not monic, you have to make it monic. So you have to take out a common factor first, and that will always be the a value. All right. Now, just before we go any further, You can see I've highlighted in the steps, step 4. It says add half of the b value squared and then subtract half of the b value squared. Now that sounds like the same thing. So that's like saying if I add 4, then I take 4 away. Now the reason we have to do that is because if you just add 4, you've changed the equation. If you take it away again, then it goes back to the original. So why are we doing this? Let's do the examples and we'll find out. Okay, first one, x squared plus 4x. Now straight away you can see there's a highest common factor. All right, we can do that this one. I've put it in there because I'm going to show you that even if you missed the highest common factor, then you can do it by completing the square as well and you get the same answer. So HCF of the first one is x. Out the front of brackets, x squared divided by x is x, plus 4x divided by x is 4. So we will end up with x brackets x plus 4 as our factorised form. All right, so if we're going to complete the square on this one, now look at step number 3, that's where we're up to. Rewrite the first two terms of the expression. So the first two terms, well, there are only two terms, so I'll rewrite that, x squared plus 4x. Now here's the bit in blue. Add half of the b value. So our b value is 4. So we're going to, half of that is 2. So we're going to add 2 squared. Okay, that's what I mean. We're going to add half of the b value squared. But then we also have to take 2 squared away because that has to cancel itself out. Now the best bit about this is, you see how I've left it as 2 squared? I didn't go and evaluate 2 squared and write 4 because these first 3 terms will always factorise as a monic trinomial to, in this case, x plus 2 in brackets all squared. So it's whatever your first term is, whatever the third term is, goes in brackets all squared. You can check it if you like, or you can choose to trust me. Now, we've still got that minus 2 squared stuck on the end, so we'll just bring that down and write that as minus 4. Now, with this one, be very careful. It's not negative 2 squared, it's minus 2 squared. So it becomes minus 4. All right, nearly there. We can factorise that again. Have a look at that. Look at that first term in brackets. That's a square, isn't it? Look at the middle there. You've got a minus, a difference, and there's a square number on the end. So we can do dots to simplify that again. So, 2 sets of brackets. What's the first square root of the first term? Is just x plus 2. Do that in the second bracket as well, x plus 2. Then we'll put a plus and then a minus. Square root of the second term, 2 and 2. We can simplify those brackets. First bracket simplifies to x plus 4, close brackets. Second one simplifies to x plus 2 minus 2, so that cancels out. So we're just left with the x. Now, if we're going to write that properly, it equals x brackets x plus 4. Would you be surprised to find out that that is exactly the same as above that we did with the highest common factor? Well done. Now, second example. We'll do the one below, I think, first. So x squared minus 4x plus 3. First step, rewrite the first two terms, x squared minus 4x. Now, we have to add, now this is always add, half the b value, which was 4, so half of that is 2 squared. Then we take 2 squared away, plus 3. Okay, underline the first 3 terms. That will simplify to x now. There's going to be a 2 brackets squared. I've left the sign out for a reason. Have a look at the difference of the first 2 equations. The first equation up top was a plus 4x and then came down into the bracket as a plus 2. This one is a minus 4x, so this one is going to be minus 2 in the brackets, okay? So you're looking for the sign in front of the b term as to what goes in the brackets. Okay, so we've got our x minus 2 squared. Now we've got the minus 2 squared on the end, which is minus 4, plus the 3 comes down at the end of it. Now simplify that end bit. We've got brackets x minus 2 again squared. Negative minus 4 plus 3 is minus 1. Have we got dots again? Yes, we have. The first one's a square, second one's a square. Square root of 1 is just 1. So it becomes brackets, brackets, x minus 2, x minus 2. There's a plus, there's a minus. Square root of 1 is 1 and 1. Simplifying that, we get in the front, x minus 2 plus 1 is x minus 1. Simplify the second bracket, x minus 2 minus 1 is x minus 3. There's our answer. Okay. Up here, x squared plus 3x plus 4. Okay, exactly the same deal. Rewrite the first two terms, x squared plus 3x plus. Now, we've got a 3, and that's a bit of an ugly number. It's going to leave us with a fraction when we halve it. So we'll just write it as a fraction, 3 over 2, all squared in brackets, minus 3 over 2, all squared, plus 4. Underline the first three terms. What do we get in the brackets? X. Now it's a positive 3, so it's a plus, and 3 over 2, close brackets, all squared. Now, minus 3 over 2 squared is 9 over 4. You see how I've evaluated that one outside the bracket? Plus 4. So we're left with brackets x plus 3 over 2, close, squared, plus negative 9 over 4 plus 4 is 7 over 4. I've done that as a fraction because fractions are friends. You can, if you're not too comfortable, and if the question says you can, write it as a decimal. So you could have said x up here, x squared plus 3x plus 1.5 squared, minus 1.5 squared, okay? If you're allowed to, decimals are fine, but fractions are friends. Okay, let's just do this last one. Now, remember, 4x squared minus 4x plus 3, these have to be monic. So, we have to take out a common factor of 4. We have to take it out of all three things there. So, the 4 comes out the front. I've just done that in green because we're going to use it again later on. Okay, brackets. 4x squared divided by 4 leaves you with the x squared, which is what you want. Negative 4x divided by 4 is negative x. Now, plus 3 divided by 4 is just 3 over 4. Again, you could use the 0.75 if you really wanted, but I'm keeping with the fractions. All right, what do we do next? The 4 has to stay there, brackets. Rewrite the first two terms, x squared minus x. Now, that's a minus 1x, so if you want to write the minus 1x, you can, just as a heads up. So half of 1 is 1/2, so plus 1/2 squared minus 1/2 squared plus 3/4. Now, you can see that 4 out the front still has to apply to that whole thing, so we've got an extra set of brackets. Okay, equals 4 brackets, comes down, still in green. Now, underline the first three terms, you get brackets x, now it's minus 1, so minus 1/2, close brackets, squared, minus 1/2 squared, which is 1/4, then plus our 3/4 on the end, and close the fourth 4 brackets. Let's simplify that, equals 4 brackets, now second brackets, x minus 1/2 squared, now minus 1/4 plus 3/4 is plus 1/2. Okay, nearly finished. Sometimes you'll see it, or not sometimes, you should see this written by getting rid of that 4 brackets. So all that is multiplying the 4 by both of the things inside the brackets. So it simply becomes 4 times the x minus 1/2 squared is, so you're just writing the x minus 1/2 squared, plus Now 4 times a half is 2. There's our final answer for that. All right. I told a little porcupine I am going to go on a little bit further after you get some practice of this. If you really want to know why we're doing all these different types of factorising, do your practice and come back and see me in a few seconds. But sir, why do we need to factorise? When am I ever going to use this in life? Well, we don't know. You may become a fireman, you may become a teacher, you may become a scientist. Who knows? But the reason we're factorising is that it just changes the look of the equation and that it gives you various bits of information. Now, we've been focusing on quadratics a little bit here, so let's just write our general form of a quadratic equation. It's y equals ax squared plus bx plus c. Okay, now the first thing that we get out of it, without doing any factorising, is the c value on the end. Just like in linear, the c value is the y-intercept. Okay, so I've given you an equation over here, y equals x squared minus 4x plus 3. Straight away, you can see the c value is 3. So we can go to a graph down here, and on the y-axis, we put a dot at 3. Done. Now, the factorising part. When you factorise, you actually get the x-intercepts. Okay, let's go back through as some revision. First thing we've got to look for, highest common factor. Is there a highest common factor that goes into any of those terms? Or all of those terms? No. Second thing, is it difference of 2 squares? Well, no, there's 3 terms, so it's obviously not 2 squares. Third one, monic trinomial. Is it monic? Yes, we've got nothing in front of the x squared, or 1 in front, but there's nothing there. X squared is monic minus 4x plus 3. Okay, let's try the monic factorising. Okay, our c value is 3, our b value is negative 4. We want to think of the numbers that multiply together to equal 3, that add together to equal negative 4. So 3 times 1, not going to get to negative 4. 3 plus 1 is positive 4. Now what about negative 3 times negative 1? So negative 3 minus 1 is negative 4. So they're the ones we want. So when we rearrange that, we get y equals brackets x minus 3, brackets x minus 1. Now, do you remember how to find your intercepts? If you let x equal 0, you get your y-intercept. You let y equal 0, you get your x-intercepts. So the short version is, we've got the two brackets there. We can simply say that our x-intercepts are 3. So it's the opposite of negative 3, which is 3. And the opposite of negative 1 is 1. So our x-intercepts, we can go to our graph, put a dot on the 1 and a dot on the 3 on the x-axis. Only other thing we need to get is a turning point. Now you hopefully know a quadratic is a parabola. Now we need to know where it turns on itself, the turning point. To do that, yes, we complete the square, as you can see. So we'll write the equation out, or the first 2 terms of the equation, x squared minus 4x. Now half of that squared is half of 4, is 2 squared minus 2 squared, and we've still got the plus 3. First 3 terms simplify to x, now it's a minus 4, so it becomes minus 2 squared, minus 4 plus 3 on the outside, leaves you with x minus 2 all squared, minus 1. So same deal, if it's in the brackets, we get our turning point from our x value is what makes that bracket 0, so 2. 2 take away 2 is 0. And the negative 1 on the outside stays as negative 1. There's our turning point. Put a dot down here at 2, negative 1. And now we simply join all the dots. Okay. Lots of applications for this out in the real world, but like I said, this is baby steps in terms of doing quadratics and factorising and expanding and polynomials you'll be getting into as you go up through high school, and it gets bigger and bigger and bigger. As you get bigger and bigger and bigger, You won't necessarily have to do this by hand. You'll be using all sorts of calculators or computers. But for now, hopefully you've got enough out of this video to get you well and truly working your way through factorising quadratics.